Awesome. So the majority of today, what I want to do, I'm going to be going over web scraping and APIs. Web scraping and APIs, they're a really interesting part of data science. It can be very finicky at times, and there's not necessarily a great way to do it at times. It requires a lot of working through problems and kind of seeing what works for each website. I'll try to lay out a specific structure, techniques you can use for web scraping using APIs. But then I'm going to go over a couple of examples and then actually post some of that code, which will be the most useful part of this workshop. Because like I said, a web scraping and using APIs, it's different for every single use case. But this will give a good overview of what to do with them and how to approach them. So quick overview, we're going to go over what's an API, using APIs, what use cases there are for them, what different APIs you can use. There's tons, I can't list all of them. We're going to go into what's web scraping, techniques and libraries used within web scraping, so how to specifically approach it, and then common mistakes, so pitfalls you want to avoid when you're doing web scraping. This relates more to connection and specifically making too many requests to a website, which you can run into a couple of errors. And then we'll do web scraping and an API example. I have two different code projects that I've done in the past, one using an API and HTML requests, and one which is a more janky web scraping. So quick, what is an API? API simply stands for Application Programming Interface and allows a user to access to a remote application. So you can think of an API similar to how a Python library works, except it's hosted remotely instead of locally on your machine. If you've ever used Python before, the little import thing on the top, you import a library. So you're literally importing the code into your computer, and then you run the code on your computer. An API is different. The code is hosted somewhere, or the service is hosted somewhere else. For example, Google Maps. If you wanted to use a Google Maps API, say you wanted to get how long it takes to travel from one coordinate to another, you'd use an API. Now you can't pull all the code for Google Maps onto your computer. That's ridiculous. It's an insane amount of computing power and you can't store it. So you'll use an API. You have a client ID, an API key, something like that, where you have access to their service, and then you can make specific requests based off of their documentation and then pull the information that's computed on their servers and then brought to your application. And yeah, the third point is allows you to integrate outside programs into your applications. This includes map services, weather reports is a super common one. Search engines is also one that you can use, but there are just tons of different APIs that are available by different companies. Some are free, some cost money. It just depends on being able to find the correct API. And so, yeah, using APIs, available APIs can be found everywhere. I'll send this link along with the presentation, your directory of APIs. You can literally just look up directory of APIs and you'll find this link. I just looked this up very quickly before this. And it presents available APIs, discusses their purpose. And all APIs are different. So it's really important to start with an API's documentation. As much as you kind of want there to be a straightforward way to handle all APIs, there isn't. Every single one is different, and so you're going to be doing a lot of reading in order to not just make the correct calls for an API, but to learn how to properly connect, learn how the data is structured, learning about how many calls you're able to make within a certain period of time. Because a lot of APIs will not allow you, will restrict the amount of calls that you make. A call being, calling the information about directions. Say you can only make like 100 calls within an hour, because if you make too many, you'll overload their servers, or they just want you to, restrict how many you're doing based off of your payment plan if it costs money. So APIs are nice though. If you can get an API for information, go with that, because API information more often than not is structured and it's a little prettier than web scraping. However, sometimes the information you need does not come in a pretty package. So that's when you would be using web scraping. So what's web scraping? Web scraping is the practice of taking unstructured data from a website, formatting it into structured data. Simple as that. And websites allow for differing levels of web scraping. So access. So sometimes a website won't even let you web scrape. To check, I'll send all these links. You can follow a website's URL with robots.txt. So for example, if we were to do www.google.robots.txt, we'd actually see a list of all the subdirectories that allow allow you to do web scraping on their website. And so some techniques and libraries that are associated with web scraping. One of them is called Beautiful Soup. I haven't used it too much, however, I'm familiar with. It's pretty easy to use, and it helps with making HTML requests, access website HTML contents, or APIs by setting GET or POST requests. And so we'll go into what GET or POST requests are in a second. There's also a requests library for Python. So import requests, simple as that. It's used for URL requests. So what HTML requests, those are one of the most important parts of web scraping and APIs. So essentially a request is just, it is what it sounds like. It's essentially you're specifying a URL to send a request to. And then if it requires authentication, if it requires like a password or something, and you include that password, then you'll get the information. If it doesn't require a password, you'll get the information regardless. There's a number of different requests. The most common is GET, in which you specify a URL, you would do requests.get, and then it pulls back the information. Typically, it'll pull back the information at the URL. So for web scraping, you'll just end up pulling back the entire code of the website, so the HTML code. And there's a couple others, put, delete. A lot of these require authentication, but we're not going to get into them today. There's another important technique, which is called XPath. You use XPath. XPath isn't as much technique as it is it's a specifier of locations within HTML files. So it's a query language for selecting nodes from an XML document. It's used on content from URL requests. Again, we'll go into all this with the examples, but say you request from a URL, say you make a request from a URL using GET. You get all of the code from the HTML, from the website, you get all the code. XPath allows you to specify a line to pick out using a specific sequence of queries. So say the code is within a specific part, say the text you want is within a specific part of the code, you can request that using XPath. And Selenium. Selenium, I haven't been able to use much. However, it's really cool. It allows you to automate website JavaScript events. So you can automate scrolling, clicking, things like that. Essentially, you're creating a bot which is able to, like it says, automate events on a website. And so if you're working with web scraping, typically you'll be using a number of these, but not all of these at the same time. So either you use like requests and Beautiful Soup together in order to pull the website's code and then to look through the code. Or you just use Selenium on its own if you want to make something that's a little more dynamic and is able to perform tasks like a human would. For example, if you want to get responses from a form and you need to click submit on a form, you may use Selenium. However, if you just want to get a list of companies that a website lists, you would just use requests in Beautiful Soup because there's no requirement to automate clicking or scrolling or things like that. So it's really important knowing the task that that's ahead of you, and then using the right tools in order to perform web scraping. So with all that, some common mistakes that you may run into. Make sure that the website doesn't block web scraping. That's super important, and it's been very frustrating if you don't check and then you wonder what's wrong and that they're just blocking you. It's as simple as that. And it's as simple as putting the robots.txt at the end of their main URL. You're able to see all the directories in which they allow and deny web scraping for. Be efficient with your requests. So when you make a request to a website and you have to say you want to gather, you have a website and you want to get all of the names of companies that the website lists. Now, you wouldn't make a request to the URL for every single company. You would make a request to the URL for the code, and then you would store the code as a string, and then you would filter through that string to find the company names. If you're not efficient with your requests, you're not only not optimizing your code, but also the second thing, you have to be mindful of the number of requests, because what ends up happening is the third thing rather, what ends up happening is that a website can block you. So if you end up making too many requests to a website will think that you're trying to attack it and trying to shut it down. And so sometimes they'll block you. Maybe they don't think you're malicious, and maybe they just block you in order to just decrease traffic. This is the case in a lot of APIs. It's the case on an API that I'll show you in a little bit that I've run into a lot. So yeah, really try to be efficient with the API or web scraping requests, HTML requests that you're making, because a website, if you make too many of them, is bound to block your IP for a period of time. And if you do web scraping enough or work with enough APIs, you'll probably run into this more in the testing phase, because you're running so many requests in order to test your code. And the final thing is know your API. Working with APIs is quite a frustrating process. Not, like I said, not every single API is built different. Not every single API is documented as well as it should be. So read up as much as you can on how each method works within the API before you use it. Understand what the output should be, so that when you are making requests to the API and something's going wrong or you're not getting the output that you want, you can easily reference the documentation and then correct the mistake. The biggest mistake that you can make while using an API is not referencing the documentation, because it should have everything there. Sometimes, though, it doesn't, and that's when it gets frustrating. So this is an outline of web scraping APIs, some of the technical stuff, some of the libraries that you can use. And now I'll go into why I think is the more useful part of this, and this will be going into an actual example. And I'll walk through the code and I'll tell you the different libraries that I'm using, and also shortcomings that that I may have had in the code, things to watch out for, pitfalls, stuff like that. So I'll stop sharing for a second and I'll share on my Jupyter notebook. In the meantime, does anybody have any questions regarding some of the stuff that we went over? Yeah, Jason, this will be posted on YouTube later. Oh, that was answered. Only show JavaScript code in the HTML. You may be making an incorrect request. Yevon, Jake, you may be making an incorrect request. So just make sure that the URL, that when you make a request to URL, you're doing like an HTML request. So it would look something like requests.get and then the URL name right there. Or you can easily see the HTML of a website if you do function 12, and then you can inspect the element, something like that. I'll go into how you do all that in the next example. First, though, I'll go over an API that was used. This is a super simple API. Yeah. Very cool. Everybody see this? Yeah, cool. So this is an API that I worked with at my last co-op. I removed the client ID and the developer API key. That's proprietary. So what this is this was an API that was used to request information regarding it was finance information. So there was a lot of IDs related to specific. Imagine Kickstarter. If you wanted an API for Kickstarter and you were trying to request information about each Kickstarter campaign. So how much money each Kickstarter campaign's raised, people that have invested in it, things like that. That's basically what this is doing. So you can see here that all this, it's super simple. All this is API request, but all this uses for the request itself is import requests. So import requests allows you, like I mentioned, to do HTML requests, and there's a bunch of different types of those. And so I'll just walk through the code first. And I already ran it. I can't run it again because I'm not going to include the client ID. And so we have specifically this variable right here. It's poorly named, but it gives us parameters that are needed in order to make requests. And so typically when you sign up for an API, they'll have like a get started button. You'll do that, and then you'll make a account with the API, and then that'll give you a developer API key and then a client ID. One or two of those things that essentially give you that authenticate you as a user and allow you to access their API. So in this case, there was a client ID and the developer API key that were specified. And here I actually store all the URL requests. So normally, so a better made API may not have you doing URL requests. They may actually have an object made of their API. So for example, Google Maps does have a object built into some languages, like if you're working in Java. They have a Google Maps, or C# actually. They have a Google Maps API object that you can use, and you can do the object dot and then reference a function that will send you the information that you need given certain parameters. This API, I talk about APIs that don't have great documentation. This is an example of one. For this, you have to do your HTML requests like we were talking about. So get, post, put, delete, things like that. So we have get trades, that gets all of the transactions that were made on each Kickstarter. Get accounts, the names of the accounts that were on each Kickstarter, trade status, offers, all that stuff. The API documentation included all of these URLs. So it should, you go to the API documentation, you go through all the methods, and you see which method returns the information that you need. And then you see what URL it's referencing, if it does, or what method it references. In this case, it referenced a URL. Say I want to get the trades. And then these are, I'll go back to this in a second. Hold up, give me a sec. Actually, no, which one do? I do get offering. Okay, yeah, I'll get, yeah, let's go to this one. So what now I do is I have a function, declaring my functions as the comment says. And so what this one does is it's called get trade status. So it just gets the status of a transaction. And so we can see here that I'm using the requests.post. And so again, reference your API documentation. The API documentation in this case specified that a post request be made. And so here in the request, the typical format is the URL first, and then you specify data. And then so data is the authentication information that you need. So in this case, the client ID. In this case, it's client ID, the developer API key. And then there's one more piece of information I needed, which is a trade ID. So say, because each transaction has an ID that's associated with it. And so this gets information about that trade. And so I specified the trade ID. And so request.post, I requested that. And then it returned all that information. And then you also can specify, so a post request can come in so when you're working with this, you want to make sure that you know what format each request comes in. So a post request can also come in with a header and then a body or content. And so the header can specify like a timestamp as to when it was requested or the type of information that you're getting. And then the body, the content, is what you want. That's the information that you're pulling. And so what I do here is I do a post request and then I do .content, which specifies, hey, reference the actual content, not the header. And then so there's With this API, it wasn't in the correct text format. So this typically won't happen with an API. Again, it's not documented correctly. You'll have to do some of this stuff. But what I have is another function called byte to dictionary, in which I input a byte string. And so I forget what a byte string is. What I do is I end up, I return I essentially take the byte string, I decode it in a specific string type, UTF-8. I replace the backslashes. And then I return the dictionary in JSON format. If you're not familiar with what JSON format is, it's essentially, JSON format is a string that specifies keys and values. And so specifies keys and values, and then you can, within code, you can reference JSON files based off of the keys, and then it will return the values, which is really nice. Well, let's see an example of a JSON or dictionary also within Python in a little bit. So we go through all this code, and then so we make this request, and so I make a different request down, you'll see though. And so I do request post, and this function returns the trade status in JSON format. I don't do trade status, I do get offer dictionary, but it's the same exact thing. The get the offer dictionary. This returns what API called an offering. It's essentially a fundraising campaign. You can think of it that way. And then I have request.post, the offer URL, which is referenced up here, that the API told us to use in order to get the offering information. We specify the data, which is offer trade parameters. We declared that up here, which is the client ID, developer API key, and then an offering ID. So this is just an ID that specifies a fundraising campaign. And then so we do .content, and then we do byte to dictionary once again. And so I'm specifying a couple of things in order to get the information within the dictionary. And then you can see JSON.dumps is like a pretty print of the JSON file, and it's right here. So this is what a dictionary or JSON may look like. And so here I could like specify issuer ID, and it would return this value. But anyway, after a lot of parsing through information, a lot of HTML requests through .post, I'm able to get this information here. And then this is the result of working with the API. I'm able to get all this information, and I'm able to utilize it in a way that I see fit. The way I did was I just made a matplotlib, simple matplotlib thing, which shows the amount of money that was raised for offerings over a time period. So this is the percent of the offering that's raised. So like what percentage of it until they reach their fundraising goal. And then this is the number of trades, the amount of people that have invested within it. So this is a basic example of working with an API. The most important things to note here are making sure you're looking through the API documentation, knowing what URLs to reference to get specific information, and then knowing what HTML requests to make. So in this case, I do request.post. And I'll send information on documentation on the Python requests, things like that. And I'll revise this code, and I'll send it, get rid of some of the noise, so it's a little more cohesive. So the last thing I wanted to show was a web scraping example, which is a little more simple. Before I go on, does anybody have any questions about that? All right, final example. Wait, actually, give me a sec. I'll do this stuff too. Cool. So, final example is this. So this is a super simple web scraper that just takes information from a website that I've specified, and I'll show the website. Oh, I didn't want to specify that. Give me a moment. Actually, no, that was correct. Anyway, here are solar providers within the United States. We have the company names on the left-hand side. This is a project that I did at my last co-op. I was requested to pull all the company names from a bunch of different pages, from it looks like 8 pages. So how do you do that? It's a great question. What I use is I use the libraries up here, LXML and requests. LXML, essentially, you can think of that similar to Beautiful Soup, same deal. And so I use something called XPath. And so an XPath, like we talked about, is a way in order to query information from a page. And so this is what an XPath looks like. It's pretty ugly. But what it specifically is in reference to, I'll show you. So if we go into the code, if we highlight that and then we go inspect, we can see specifically where this is made within the code, where this name is specified within the code. And so we can see all the code right here. If you're familiar with HTML, this makes a lot of sense to you. The XPath, what we do is we like specify the tag path essentially to this name. If you're not familiar with HTML, HTML is a series of, it's a language for developing websites, technically not a language, but what we specify is we specify a bunch of tags, and the tags have each a purpose. These create like headers and bodies and things like that. And so we can specify a tag path in order to get to here. And so what we can do once we're here is that we can pull this information. And so say instead we wanted to get on or off the grid, or no, let's do company name. Say we wanted to get the company name. We go to inspect, we see it right here, and then we'd right click in the inspect element, and then we can go to copy and then copy XPath. So copy XPath will then return the path within the code to the company name. Simple as that. So you see, we already have it. So let's go to the bottom here. I'll just print out the XPath that I copied. We can see that it's similar HTML body div 3, all that stuff. Table T body. And so you can see that this is a little different. And so XPath isn't going to be perfect. If you saw from when we made that request, we actually have everything here highlighted. So if we make an HTML request and then we specify where to look for the information based off of this XPath, it'll return all this information. It'll return like the tag, the on click, and then the link, and then the name, and then the end tag. We don't want all of that. Also, the XPath right here specifies the TR right here. That's specific to the page. I found that out just through trial and error. Again, a lot of the stuff is just trial and error. But you can see that I specify the page through these comments, the curly brackets. With the curly brackets, I can specify the page that I'm on through Python format. So you can see that I did that here. And then what I do is each page contained 100 sorry, no, TR specifies not the page, it specifies the company number. So the next XPath, so the first company would have TR1, the next one would have 2, so on and so forth. And so right here I do a for loop. I go through the numbers 1 to 100. It's exclusive because each page only goes through 1 to 100 companies. And then I just set S equal to the XPath, and then I have a dictionary, or an array rather, in which I just add the XPath. And then what I do is, now that I have all of my XPaths, what I do is I go through range 1 through 9. It goes through pages 1 to 8. 9 is exclusive. And then I specify the page that I'm on. And then, so the page is equal to the request. So requests.get. I'm just making a URL request to that website, to that link that we looked at. And then page is equal to curly brackets. So this value right here that I'm highlighting is going to change with every loop. For the first loop, it's going to be page equals 1. Second one, it's going to be page equals 2, 3, then 4, until we get to 8. As we remember, There's 8 pages in total. And then so we have, we specify we make the HTML code into a tree. And so this, you can look through documentation of LXML, and this is something that formatting they suggest they do. And then I go through a for loop again, and I go through all the XPaths specified within my dictionary, my array of XPaths. And then this will get me every single company listed on a page. And then so the last page doesn't have exactly 100 companies. So I just, it was janky, and I did a catch exception in which I just, if the XPath wasn't valid, it didn't point to anything, I just threw an error. And so you can see here that S is equal to tree.xpath. So tree is the code, and then .xpath. XPath is a function within this library. And then I give it an XPath, and then I get the content, which is on the 0th, on the first index of the array. And so then printing XPaths. So I can just run it real quick, and I can show you what it's going to look like. We can see here within, it's specifying all these, and you can see the TR right here, like 88, 89, 90, that's specifying the company. Then we go to page 4, page 7, page 8, and then it prints out all the companies correctly, and we have them all listed here. So this is an example of not using APIs but web scraping. A pretty simple example, and I'll also include this code. And then the printing it all out, that's just file IO stuff with Python. So there's a lot that goes into web scraping. The biggest thing I would say about web scraping and APIs, knowing the libraries how to use, knowing how to use them, pay attention to the documentation of the API, and lastly, just be patient with it. It's a tedious process at times. There's a lot of learning that goes into it because it's not an exact science, and it can be finicky at times. But just be patient, and it can be extremely rewarding at the end, and being able to get structured data and completing a project.